Hello my friends, welcome back. This is the second lecture of the soil mechanics series. In the last lecture I talked about some basic definitions and relationships between several parameters that we need to know for this course, and I also talked about phase diagrams, and in this lecture I am going to talk about how to determine water content of a soil sample experimentally. Well, in the last lecture, we discussed what is water content. So, water content, as we discussed, well, it represents the amount of water present inside a soil sample. So, water content can be represented by small w. It is the ratio of the weight of the water present inside the soil sample to the weight of the solids or dry soil, both the same. It can be also expressed in terms of percent. So, water content can be determined in using various methods, but popularly only two methods are used. The first one is oven drying method, and the second one is the pycnometer method. So first I am going to talk about oven drying. Suppose you have a container, a empty container. The weight of that container, suppose, is W1. Now you have a moist soil sample. You put it in the container. This is your moist soil sample. You weigh it. Suppose the weight is W2. Both the container and the moist cells, the weight is W2. Now you oven dry it. You put it in a oven. You oven dry this sample for 24 hours. For 24 hours at 105 to 110 degrees centigrade. Okay, because if you increase the temperature beyond 110 degrees centigrade, then the crystalline structure of the clay may get destroyed. So you need to maintain the temperature. So after 24 hours, you need to take the soil sample out from the oven and cool it down using a desiccator. So after cooling, you will so after cooling, the moist soil sample, all the water will get evaporated from the moist soil sample. It will be totally dried. So this one is now dry soil sample. So now if we take the weight of this dry soil sample including this container, suppose the weight is W3. So what is the weight of the water that was present inside the moist soil sample before drying? So weight of the water is, if we subtract the weight of dry soil from this moist soil, we will get the amount of water, the weight of the amount of water that was present inside the moist soil sample before drying. So we can write it like this. Okay. And what is the weight of the dry soil? Weight of the dry soil is equal to W3 minus the weight of the container. So the water content can be written as weight of the water divided by weight of the dry soil or soil solids is equal to W2 minus W by W3 minus 1. It can also be expressed in terms of percent. So now let us discuss about the second one, the pycnometer method. Well, What is picnometer? Well, basically it is a glass bottle having a conical top, the capacity of which is 900 milliliter. Here is the picture of a picnometer. This is the picture of a picnometer. Okay. So suppose this rectangle represents an empty picnometer. Suppose the weight of the picnometer is W1. Now you have a moist soil sample. You put it inside the picnometer. Okay. Well, a moist soil sample means there will be solids and some water. Suppose this is the picnometer. Inside the picnometer, you are putting a moist soil sample. Suppose this is water, this is solid. So the weight of this picnometer plus moist soil is W2. Now you need to add water gradually inside this picnometer where the soil is present, moist soil, and you need to stir it properly. Okay, so you need to water gradually and stir it properly. So it will be like this, only solid portion will be present and rest will be all water. And if we weigh it, after that the weight we will get is W3. And after weighing this, we need to empty out all the content, and we need to fill it up with water and weigh it again. So only water is present and the weight is W4. So now what is the amount of water present inside this moist soil? Okay, this moist soil, what is the amount of water present inside the moist soil? We can write it like this: W2 minus W1. I am subtracting the weight of the container from this, so we will get the weight of the moist soil. Now if we somehow manage to subtract the weight of the solid portion, we will get the amount of water present inside the moist. Is it okay? Now let us focus on these two diagrams. Now look here, suppose if we somehow can replace this portion, the solid portion, with an equivalent volume of water and weight, it will be same as W4, isn't it? So we can write it like this: W4 is equal to W3 minus Ws. We are replacing the solid portion with an equivalent volume of water. Okay, so it will be same as W4. So what is this equivalent? What will be the equivalent amount of water? We need to determine that. The weight of the equivalent amount of water, we can write it like this: unit weight of water into volume of solids, because the volume will be same, because we need to replace this particular volume with the same volume of water and weigh. So it will be like this. So after that, we know G equal to Ts equal to gamma S by gamma W. Okay, we can write gamma S equal to Ts gamma W, and gamma S is equal to weight of the solids by volume of solids equal to gamma W. Now the volume of solid is equal to weight of solids by specific gravity of solids into unit weight of water. Now as we have written here, over here, this and this. So the equivalent amount, suppose now we need to put it over here. So equivalent amount of water, the weight of the equivalent amount of water will be gamma W into volume of solids, which is this. This is the volume of solids. So it will be like this: Ws by specific gravity of solids into gamma W. It is Ws by Gs. So the W4. So now this equation, what was the equation? W4 equal to W3 minus Ws plus weight of equivalent amount of water. So you can write it like this: W3 minus Ws plus Ws by now we can simplify this a bit. Equal W3 minus W. We can write it like this: if we take Ws common, we'll get 1 minus 1 by Gs equal to W3 minus W. Gs equal to W3 minus W4. And now the weight of the solids is equal to W3 minus W4 by Gs minus 1 by. So here we get the weight of the solids. Now water content is defined as the weight of the water to the weight of the solids. So what is the weight of the water we determined in the first place? Is this one, weight of the water that is present inside the moist soil. So it is W2 minus W1 minus Ws by Ws. Now if we simplify it a bit, it will be like W2 minus W1 by Ws minus. Now we need to put this equation of Ws over here. So we will get equals to W2 minus W1 divided by W3 minus W4 into Gs minus 1 by Gs, and there is a minus 1, so minus 1. So this is the formula for determining water content using picnometer method. It can be also expressed in terms of percent. So this is all for today. In the next class, we will discuss how to determine the specific gravity of solids, and as well as how to determine the in situ density of soil experiment. Thank you. See you in the next lecture.